Welcome to Eternal Vault. Let's begin now discuss another new topic. The universe is vast and mostly silent, but sometimes it sends us a message, a whisper from a distant unknown shore. Imagine a traveler, journeying for millions of years, drifting through the void between stars, carrying the dust of a home so far away its light hasn't reached us. Now that traveler has arrived at our cosmic doorstep. In early 2025, a faint streak of light was captured by new sky surveying telescopes. At first it seemed unremarkable, just another comet or asteroid. But astronomers soon realized it was moving too fast. On a hyperbolic trajectory, it came from beyond our solar system. This was a visitor from interstellar space, a postcard from the stars. The discovery electrified the scientific community and the world. For the first time, we had a chance to study a piece of another solar system up close. The object, soon named 3I/Tails, became a symbol of the unexplored wilderness that surrounds us. Its path would whip it around the sun and fling it back into the galaxy, a fleeting opportunity. Every telescope and instrument was readied for this rare event. The universe had sent us a gift, and humanity was ready to unwrap it. The age of interstellar archaeology had begun. The clock was ticking. What is an interstellar object? Think of our solar system as a neighborhood. Our planets, asteroids, and comets are the residents, all bound to the sun. An interstellar object is a tourist from a different star system, not bound by our sun's gravity. Instead of orbiting, it speeds through on a hyperbolic path, just passing through. These objects are physical pieces of another part of the galaxy delivered directly to us. For most of history, visitors from other stars were pure speculation, but now we can study them up close, cosmic time capsules from unknown suns. By analyzing their composition, we learn about the chemistry and conditions of their home systems. Do they have water, organics, strange isotopes? Each clue brings us closer to understanding their origins. These messengers carry vital information about how other solar systems form and evolve. They might even hint at whether the building blocks of life are common across the galaxy. Interstellar objects are the ultimate cosmic archaeologist's finds. Before 3I/Tails, two pioneers blazed the trail, 9 Oumuamua and 2I/Borisov. Oumuamua, discovered in 2017, was a bizarre, elongated object with no visible tail, yet it accelerated away from the sun, sparking debate about its nature. Was it outgassing, exotic material, or even alien technology? We may never know. It slipped away too quickly for answers. 2 years later, 2I/Borisov arrived, behaving like a classic comet, large, with a bright tail, and familiar ingredients like water and carbon monoxide. Borisov proved interstellar objects weren't flukes. They could be detected and studied. It showed that other solar systems could form comets much like ours. Together, Oumuamua and Borisov set the stage for the next, even more spectacular arrival. They taught us to be ready, to watch the skies, and to expect the unexpected. Each visitor brought new questions and new excitement. The galaxy, it seemed, was more connected than we ever imagined. These discoveries were just the beginning. The next visitor would offer our best chance yet to unlock the secrets of the stars. And that visitor was 3I/Tails. The story of 3I/Tails began with a quiet stream of digital data in spring 2025. The Aryabhata Sky Survey in Ladakh, India, designed to find faint, fast-moving objects, flagged a fuzzy dot moving at high speed. Dr. Aris Thorne's team quickly realized its trajectory was hyperbolic. It was coming from deep space. The international community was alerted, and telescopes worldwide turned to observe. Officially designated 3I/2025 F1, it soon earned the nickname 3I/Tails. Early observations showed two distinct tails, a sign of an active comet. Its speed, over 150,000 kilometers per h, confirmed it was not from our solar system. Unlike Oumuamua, 3I/Tails was discovered on its way in, giving us months to prepare. Scientists could now watch its entire journey, from approach to departure. This was the opportunity astronomers had dreamed of, a close-up study of an interstellar visitor. 3I/Tails was a hybrid, part comet, part mystery. Like Borisov, it had a bright coma and spectacular tails, but its brightness fluctuated rapidly, hinting at a fast spin and a violent past. Its twin tails were unique, one of water, ice, and dust, the other rich in complex organics like methane and ammonia, in never-before-seen ratios. It was as if two different comets had merged into one. Its trajectory was slightly off, thanks to asymmetric jets of gas, visible evidence for the mysterious acceleration seen in Oumuamua. As it neared the sun, the jets flared, making it a dynamic, unpredictable spectacle. The nucleus was about 2 kilometers wide, but its coma swelled larger than Jupiter. Amateur and professional astronomers alike were treated to a celestial show. 3I/Tails was a living piece of another solar system, performing in the grand theater of space. It was a breakthrough in understanding interstellar visitors, and it was just getting started. The discovery of 3I/Tails sparked a wave of global scientific collaboration. Observatories worldwide, from Chile to Hawaii, and space telescopes like James Webb, all focused on this cosmic guest. Data was shared openly and in real time, accelerating discovery. Scientists learned more about 3I/Tails in days than during all of Oumuamua's passage. Optical, infrared, and radio telescopes worked together to analyze its color, heat, composition, and structure. India's Aryabhata survey was celebrated for its pivotal role. The event inspired a new generation of scientists and students. 3I/Tails became a story of human ingenuity and cooperation. It showed that, united, we can unlock the universe's secrets. The world watched and learned together. What was 3I/Tails made of? The answer was both familiar and strange. Its primary tail was mostly water ice and silicate dust, common building blocks for planets and life. The second tail, however, was rich in frozen methane and complex organics called tholins, never before seen in such abundance in a comet. Tholins, found on Saturn's moon Titan, are key precursors to life. Their presence suggested that the chemistry for life can form in distant solar systems and travel across the galaxy. Radar data showed 3I/Tails was a rubble pile, a loose collection of icy and rocky chunks. It may have formed from the collision of two different bodies in its home system. These findings painted a vivid picture of a diverse, mature solar system, much like our own. 3I/Tails was a geological sample from another world, telling the story of its distant birthplace. It hinted that the ingredients for life are common in the cosmos. Whenever an object from the stars acts strangely, the question arises, could it be artificial? 3I/Tails. Dual composition and asymmetric jets made it an outlier. SETI and others listened for signals. None were found. The consensus, 3I/Tails was a natural though extraordinary object. Its weirdness could be explained by known physics and chemistry. Nature, it seems, is more creative than we imagine. This doesn't diminish the excitement, it enhances it. The discovery shows that the galaxy is full of complex, dynamic worlds. Science thrives on challenging assumptions and exploring possibilities. 3I/Tails reminds us to keep looking and listening. One day, a visitor may arrive that truly defies explanation. The passage of 3I/Tails was more than a scientific event. It was a philosophical one. For months, humanity looked up together, united by curiosity and wonder. This small visitor reminded us of our place in the vast universe. We are part of a galactic ecosystem exchanging material with other stars. The discovery inspired new missions. One day we may send a probe to meet an interstellar traveler. Visitors like Oumuamua, Borisov, and 3I/Tails expand our horizons and challenge our understanding. They urge us to keep exploring and never lose our sense of awe. We live at the dawn of interstellar discovery. The sky is not the limit, it's an invitation. The universe has many more secrets to share, and the next messenger is already on its way.